So a horizontal asymptote is a horizontal line that tells you how the function will behave at the very edges of the graph, or for very, 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 very large values and very, 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 very small values. A horizontal asymptote is not sacred ground, however. The function can touch and even cross over the asymptote. So we're actually going to see a graph today that talks about that, where the horizontal asymptote is like let's say y equals 2, and the graph does something like this, and it hovers, and it hovers. So there are times when it could cross the asymptote. I know it seems like, I always mention that, like, it'll get close to the asymptote but never touch it. But there are times when it'll cross over and then immediately go next to it. So that's why they said it's not sacred ground. Horizontal asymptotes exist for functions where both the numerator and denominator are polynomials. These functions are called rational expressions. Let's look at one to see what a horizontal asymptote looks like. All right, so here are the rules. So if we're given a rational function where a x to the nth is the lead term of the numerator, and bx to the m is the lead term of the denominator, what we're going to pay attention to is the biggest exponent, or the degree of each of the denominator and the numerator. So we have to look at, before we can find any kind of asymptotes, what is the exponent in the numerator, what is the degree or the lead exponent in the denominator, and then that'll determine how we find the asymptote. Now notice we're focusing on a horizontal asymptotes because hopefully vertical asymptotes you guys feel really good about, because that's the same thing as finding the domain of a rational expression. So you're basically looking at the denominator and seeing what makes that equal to 0. That's why today's focus is mostly on the horizontal asymptote, because that's something that I think it's been a while since you've seen that. And because last March, pretty much everything shut down, so I'm not sure how much you got into this last year. All right, so here are the 3 rules. When n is less than m, the horizontal asymptote is y equals 0, or the x-axis. So this is the example of if I have y equals x over x squared minus 1. If you look at the exponents here, this is 1 and this is 2. Since 1 is less than 2, then this would have the asymptote of y equals 0. Now, I know some of you guys are like, I just can't memorize anymore. This whole year has been just too much for me. Okay, just take a deep breath. You can use Desmos. So you can verify this graph, x over x squared minus 1, using Desmos. So y equals x over x squared minus 1. Okay, and you see along the line x equals y equals 0. I'll graph that next. They did it in black. Let me get a different color here if I can. I can't. All right, so they did it in black, but you see the darkened in x-axis. That's the horizontal asymptote. Now the vertical asymptotes are what make the denominator equal to 0, but in this case, -1 and +1. And that's why you have 2 vertical asymptotes at x equals -1 and x equals +1. All right, so, but today's focus is mostly on horizontal asymptotes because vertical asymptotes are easier to find. All right, now, here's a second scenario. And these first 2 scenarios are the ones that you're most likely going to see. When n is equal to m, then the horizontal asymptote is equal to y equals a over b. So if I have an equation that looks like this, y is equal to x squared plus 4 and x squared plus 4x plus 4. So in this case, they have the exact same power, the same degree, And the horizontal asymptote would be y equals 1 over 1, or just 1. Because that's what the lead coefficient is. So when they refer to A over B, they're referring to this example over here. A is the lead coefficient of the numerator, B is the lead coefficient of the denominator. And to find the horizontal asymptotes, if they have the same degree, it's just A divided by B. And again, I know it seems like a lot, but you can always use Desmos. So x squared plus 4 divided by x squared plus 4x plus 4. Okay? And so we said that the horizontal asymptote was at y equals 1 because of the coefficients of the numerator and denominator. So let's see what y equals 1 looks like. We see that purple line, your graph, it does cross it, right? And we said that that could happen. It crosses it, but then for the rest of the time, it's hovering along that line. You can just kind of go back and forth, and you see like, oh, yeah, I see it. Y equals 1. All right, and then lastly, when n is greater than m, there is no horizontal asymptote. All right, so y is equal to x squared plus 3x plus 2 all over x minus 1. In this case, the numerator has a higher exponent than the denominator, so there is no horizontal asymptote. So x squared plus 3x plus 2 divided by, let's say, x plus 1, or x minus 1. Okay. Actually, instead, we get something called a slant asymptote, which is what you're looking at right now. Or an oblique asymptote is sometimes called. Okay. So we're not going to study that, and that's why we said there's no horizontal asymptote. We're not concerned about the oblique or slant asymptotes, okay? But you can clearly see there's no horizontal because there's nothing like a y equals equation that goes there. All right, so for the most part, we're going to be focusing on examples like 1 and 2, not so much a third one. All right, so let's get a feel for this. And I'm just going to put the vertical asymptote here just as a challenge, so you can check this out. So when you're looking at these kind of equations, you're going to have 3 of them on the final. I mean, the first thing I would do is graph it. So I'd go on Desmos and kind of confirm my ideas, but I wouldn't stress out about it. I'd just go right to it. So 2x squared minus 11 over x squared plus 9. So 2x squared minus 11 all over x squared plus 9. Okay, so we see kind of a strange looking graph here. Now what we got to notice is that they are the same, they have the same degree. So they're both degree 2. And when that happens, that means that their horizontal asymptote is just the lead coefficient of the numerator divided by the lead coefficient of the denominator. Or in other words, it's y equals 2 over 1, or just 2. And if you look at this, see how the graph is hovering around that green line there? Okay, that's your horizontal asymptote. Right, and where does that come from? Well, we talked about it comes from when n is equal to m. When they're equal to each other, it's just the lead coefficients divided by each other. So in this case, it's y equals 2 over 1, or just 2. Now, as far as the vertical asymptote, when you looked at the graph, you probably didn't see one, and that's because there isn't one. When you have your denominator like x squared plus 9, and when we find a domain, we always set it equal to 0, right? We're trying to figure out what makes the denominator equal to 0. In this case, there is no real number (3i). In this case, there's no real number that works, right? It's 3i, which is an imaginary number. In this case, there's no vertical asymptotes, all right? Now, since the test is multiple choice, you don't have to worry about like plotting a table of values to graph it. You could just, again, you're trying to get a feel for this graph, and you could just kind of sketch it. So it looks something like this, okay? Again, you are not graphing on this test. You're going to look at multiple choice pictures of graphs, and you have to pick it out, which again, you can just use Desmos for. Okay, over here, the second example, again, we got to pay attention to the exponents. These exponents are the same. They're both x squared and x squared. So my horizontal asymptote is y is equal to 5 over 3, which is a little less than 2. Now my vertical asymptote, I got to factor this if possible to see what makes it equal to 0. And I'll just tell you, these are all imaginary solutions. So again, there's no vertical asymptote. Okay, so I already did the work for you guys, don't have to worry about that. But first things first, you get a question like this, go right to Desmos. So 5x squared plus 2x minus 4. Divided by 3x squared minus 2x plus 9. And again, you see no vertical asymptotes. There's no up and down line that would give you that. And we see that the lines are starting to like level off somewhere. And where do they level off? Well, at y equals 5/3. And you see right there that black line, it is not going above it. All right. So again, I want you guys to get a feel for this. So instead of finding a domain, I want you guys to find the horizontal and vertical asymptotes, horizontal and vertical asymptotes. So you guys are going to do these on your own, then that's it, right? I said it was quick notes today. So looking at number 1 and 2, first, the exponents. This is to the first power. This is to the second power. Hold on. Oh, go back up, yeah. All right, so first power, second power, I'll go all the way back up. When n is less than m, the horizontal asymptote is y equals 0. So my horizontal asymptote, since n is less than m, it's y equals 0. My vertical asymptotes, okay, I'm trying to see, well, what makes this equal to 0? Well, x squared minus 2x minus 10 is not factorable. So I have to use the Pythagorean, or the quadratic formula. So minus -2 plus or minus the square root of -2 squared minus 4ac all over 2a. X is equal to 2 plus or minus the square root of 44 all over 2. X is equal to 1 plus or minus root 11. So my two vertical asymptotes are x equals 1 plus root 11, x equals 1 minus root 11. And if you graph this, which again, you got to do it, so 2x minus 1 over x squared minus 2x minus 10. Okay. So you see three asymptotes, the line y equals 0, and then the two vertical ones, I'm not going to put those in. But you see how the lines are going up and down very sharply. Those are your vertical asymptotes. All right, now looking at number 2, again, pay attention to the exponents. This is 2, this is 2. They are the same. So what do we do when they're the same? When they're equal to each other, then the horizontal asymptote is a over b. Or in this case, negative 3 over 1. Now for the vertical asymptotes, again, that's always the same. This is why I'm not too worried about this. What makes the denominator equal to 0? Well, in this case, x minus 7, x plus 7 equals 0, x is equal to negative 7, x is equal to positive 7. So my vertical asymptotes are x equals 7, x equals negative 7. And now I can confirm this. Negative 3x squared divided by x squared minus 49. And there you go. All right. So it's hovering around the line y equals negative 3. And there's vertical asymptotes at x equals negative 7 and x equals positive 7. And you see those lines forming. You see how the graph is basically built around those lines. Right? Those are the asymptotes. Those contain the graph. So pretty much, you could use decimals to back up your answer, right? But it helps to have knowledge on especially numbers 1 and 2. All right, for the last thing here, we're not going to do these, but can you, on your own, tell me what is the horizontal asymptote and the vertical asymptote of these two equations? All right, so let me give you like a 2-minute head start here. Tell me if you can identify the horizontal asymptote and the vertical asymptotes on your own. It's super delayed. I already got all these. Okay. So you guys have enough time to figure this out. All right, so I don't know, which one do you guys think is easier? Finding the horizontal asymptote or the vertical asymptote? What's finding the vertical? Okay. All right, so finding the vertical, we got to set this equal to 0, and we're factoring, right? Sometimes we factor, sometimes we just, it's given to us. So in this case, it worked out nice. X minus 6, x plus 4 is equal to 0, x is equal to 6, x is equal to negative 4. So these are our two vertical asymptotes. How do I know that they're vertical? Besides the fact that I took it out of the denominator. What lets you know that it's vertical? What kind of equations are those? What letters does it start with? X, right? X equals lines are vertical lines. So automatically you know that those are going to be your vertical asymptotes. All right, now for horizontal asymptotes, we have to pay attention to the exponents. So this is to the first power, this is to the second power. Let me go back up here. When n is less than m, the horizontal asymptote is y equals 0. Oh, okay. So I don't really have to do anything. I just got to write down y equals 0. So how many guys got that for number 3? Yes? Yeah? How about the virtual world? Give me a thumbs up. How many of you guys got that? Very good. Very good. Awesome. All right, and the last one. 3x squared minus 9x over x squared minus 9. So let's find the vertical first. So x squared minus 9, that's x minus 9, and or x minus 3, x plus 3 equals 0, x equals 3, x equals negative 3. So my vertical asymptotes are negative 3 and positive 3. And my horizontal asymptote, well, this is 2, this is 2. If they're the same, then it's just the lead coefficients. So y is equal to 3 over 1 or just 3.